Dear students, we have talked about the boron, carbon, nitrogen and oxygen family in the previous segments. In this segment, we will focus on the halogens and noble gases. Let us start. The group 17 elements are the halogens, that is fluorine, chlorine, bromine and iodine. We do not talk about acetylene much, that being radioactive. So, our focus will be on fluorine, chlorine, bromine and iodine. Starting from how do they exist and what color do they have. So, fluorine is existing as a yellow gas, chlorine is existing as a greenish yellow gas, bromine is a non-metallic liquid, please remember, okay, and iodine is violet color solid. This thing has been asked in the exam, that in which state or which of the following is existing as a crystalline solid. Most of the students thought that I do exist as a gas, but it is a violet colored solid, right. Now, when we talk about these molecules, there is some interesting fact that when we discuss the bond dissociation enthalpy, see, the bond dissociation enthalpy of fluorine is lesser than that of chlorine, in fact bromine. Why? Because the size of fluorine is so small, because of which there are high repulsions between the lone pairs of fluorine atoms. That is why the bond dissociation enthalpy of fluorine is lesser than that of chlorine as well as bromine, okay. Other properties like atomic and ionic radii, they basically increase down the group, their radii is smallest in a respective period, right. And why their radii is smallest? Because of the maximum effective nuclear charge, right. Down the group it is a general increase. When it comes to electron gain enthalpy, these elements have the highest electron gain enthalpy in the periodic table, chlorine being the element having the highest electron gain enthalpy. Why not fluorine? Because in the case of fluorine, the size of 2p orbitals is small, so strong repulsions will occur, right, something similar to oxygen that we studied. So, down the group, the value of electron gain enthalpy becomes less negative, but that of F is less than that of chlorine due to the small size and high interelectronic repulsion due to the compact 2p orbitals of fluorine, right. Electronegativity, fluorine is the most electronegative element of the periodic table, followed by oxygen, then nitrogen, which is equivalent to chlorine, and after that comes bromine and iodine, okay. Have a look at the chemical properties of all these halogens individually. When you pick up fluorine and you react it with water, you will be getting the H plus and F minus ions in solution and oxygen gas will be released. Apart from fluorine, if you talk about chlorine and bromine and you add it to water, you will be getting HX and HOX, means halide, hydrogen halide and hypohalide, right. Here please remember X is only chlorine or bromine. Now, what happens in the case of iodine? The I minus ion, if suppose we add it to water and we get H plus and I minus and oxygen is being released, the oxygen is then oxidizing this I minus to I2 once again. So, in a way the reaction becomes reversible, right. Another important point is the halo acids, from which many times the questions have been asked, starting from the acidic strength. Why the HI is the most strongest acid out of these four? Because of the larger bond length. In fact, dear students, there are 3 points. Normally we think that fluorine is more electronegative, so it can strongly pull the electrons from hydrogen. Yes, it can pull, but can it keep the electrons? Fluorine can pull, but it cannot keep. Why? Because it has got a small size. So, repulsions would be there, right. Also, when you are talking about the release of H plus, you are getting an anion. So, you have to talk about the solvation energy also over there. So, one is the electronegativity, second is the electron density, third is the solvation energy and fourth is the bond length, right. So, out of all these, the bond length criteria wins and HI is the strongest acid because H plus can be easily released in the solution, okay. This is the order of bond dissociation enthalpy. As you go down the group, the bond length increases, thus bond dissociation enthalpy decreases. Stability, HF is the most stable. Boiling point wise, yes, as you are going down the group, in case of HF, yes, there is hydrogen bond, but otherwise as you are going down the group, the van der Waals forces will come into the picture. So larger the size, more should be the boiling point. So you see HI is having the higher boiling point as compared to HBr and HCl. Why HF is at the first? Because of hydrogen bonding. Now these two questions have been asked in the exams regarding the comparison of melting and boiling point of H2O, NH3 and HF. In any case, H2O is having the highest value because the melting point is 0 degree, boiling point is 100 degree Celsius. When you talk about ammonia and HF, what we are observing, starting from the melting point, HF is having a lower melting point, somewhere in the range of minus 80 degrees Celsius, and ammonia is having somewhere around minus 77 degrees Celsius. Whereas in case of boiling point, if we see, HF is having a higher boiling point as compared to ammonia. The reason is the extent of the hydrogen bonding in the solid as well as in the liquid phase. So in the solid phase, NH3 is having a stronger hydrogen bond or a better 3D network, whereas in case of liquid, HF is having a stronger hydrogen bond, right? Now let's talk about the properties fluorine on addition to water. If you are adding smaller quantity of water, you are releasing oxygen. If you add a higher quantity, ozone will be released. If you react fluorine with dilute NaOH, you will be getting OF2, whereas when you react it with concentrated NaOH, you will be getting the oxygen gas. These two reactions are in particular very important, can be asked in the exams. Okay. Chlorine, when reacts with excess of ammonia, will form ammonium chloride, but when chlorine is in excess, you get NCl3. These two reactions are very important. When chlorine reacts with cold and dilute NaOH, you get NaClO and NaCl, whereas when you react with hot and concentrated NaOH, you get NaCl and NaClO3. Please remember, both of these are disproportionation reaction. Chlorine is having a zero oxidation state over here. In NaClO, it is +1, NaCl -1. So from 0 to +1 and 0 to -1, disproportionation. Here it is Cl is -1, in NaClO3 it is +5. So -1 and +5, once again disproportionation reaction. Okay. Let's talk about iodine. In cold and dilute, similar to chlorine, it is forming NaI and NaOI, and in hot and concentrated it forms NaI plus NaIO3. This reaction in particular is very important, has been asked in the exam specifically about the N factor of this particular iodine molecule. My dear friends, please remember, in this equation 5 electrons are being transferred. This is a disproportionation reaction. The N factor of this iodine is 5/3. Okay. Now let's talk about the interhalogen compounds. See, the halogens can combine with each other, forming various interhalogen compounds, ClF, ICl3. Please remember, they can ask you about the hybridization, shape, number of lone pairs from these specific examples that I am giving. ClF3, it is sp3d hybridization and it is T-shaped, and BRF3, BRF5 is square pyramidal, right? ICl, all these are interhalogen compounds, and the interesting part is that these interhalogen compounds are more reactive than the parent halogen. Why? Because in this interhalogen compounds, the bond strength is lower as compared to the bond strength of individual halogen molecules, right? So XX dash bond is in interhalogen is weaker than that of XX bond in halogens, right? Next thing, all these undergo hydrolysis giving halide ion. Please remember, halide ion will be derived from the smaller halogen. So you see over here, X dash is the, we are taking X dash as the smaller size halogen and more electronegative. Okay. So this X dash will form the halide ion. See, it is forming the halide ion. And the X will form, like in this case, it is forming hypohalite. Hypohalite when XX dash, halide when XX dash 3, halate XX dash 5, and perhalate when XX dash 7. This is a very important point. Please note it down. Over here I am taking XS dash, so I am getting HOX. If you take X XX-3, then you will be getting HXO2. XX-5 will get HXO3. XX-7 you will get HXO4 apart from HX. Okay, fine. This is very important for you. Now let's look at a question. The question says that in which of the following arrangements the sequence is not strictly according to the property written against it. HF, HCl, HBr, HA, increasing acid strength. This is right. This is right. We have to find out which is not right. This is correct. Second is increasing basic strength ammonia. No, this is wrong because ammonia is more basic as compared to phosphine. So this is the right answer, but let us have a look at the other ones as well. Increasing first ionization energy, yes, nitrogen is more than that of oxygen. Why? Because of the extra stability of half-filled p orbital configuration. Let's look at the other choices also. The third choice says that this is the increasing order of first ionization energy, which is correct. Carbon is more than boron. Why? Because of a smaller size. Oxygen is more than that of carbon, again smaller size. But why nitrogen is maximum? Because of the extra stability of half-filled p orbitals. Carbon dioxide, silicon dioxide, tin dioxide and lead dioxide in the increasing oxidizing power. Yes, because as you are going down the group, the ability to release oxygen is more. Also, lead is more stable in the +2 state as compared to the +4 state. Anyways, the correct answer is choice number 2. Which among the following is the most reactive? Interhalogen compounds are more reactive as compared to the halogens, right? The product obtained when chlorine gas reacts with cold and dilute aqueous NaOH. So in cold and dilute you get Cl- and ClO-, right? This is the right answer. HF has highest boiling point among hydrogen halides because of strongest hydrogen bond. So first is the right answer. Now let us talk about the group 18 elements. Here this xenon fluorine compounds are very important, so we will talk about them. Xenon fluorine compounds. If xenon in excess combines with fluorine at this temperature, you will get XeF2, but as you increase the quantity of fluorine, like over here xenon is 1, fluorine is 5 times that of xenon, at higher temperature and higher pressure we will be getting XeF4. The hybridization, number of lone pairs, geometry, shape, all are important for all the xenon fluorine compounds that you get. Okay, so make it necessary that wherever you are writing a xenon fluorine compound, you are writing the hybridization, you are writing the geometry, you are writing the shape, you are writing the number of lone pairs. Okay, now let's go ahead. If you increase the fluorine in 1:20 ratio, you will get XeF6, XeF2, sp3d hybridization, sp3d2, sp3d3. Okay, fine. Now this hydrolysis part is very important. When you hydrolyze XeF2, you will get Xe plus 4HF plus O2. They can ask you the equation directly, my dear friends. Okay, XeF6 on hydrolysis gives you XeOF4 plus 2HF. If you increase the amount of water, you will be getting XeO2F2, and in basic medium you will be getting XeO6F4 minus plus xenon. Also oxygen gas is being released out, right? All these reactions, apart from that, if you catch hold of any other reaction that is available, please go through it. Nowadays they are asking questions based on these reactions very specifically. Okay, let us have a look at some of the questions. The question says, which one of the following reactions of xenon compounds is not feasible? Okay, so the first reaction XeF4, this is feasible. Second, XeF2 plus water, this is feasible. XeF6 RBF, this is feasible. XeO, see, this is not feasible. Why the fourth reaction is not feasible? Because this XeF6 will further undergo hydrolysis. This XeF6 will further undergo hydrolysis, thereby producing XeO3 once again. So that is why the correct answer is fourth, because XeF6 will further react with water, making XeO3. Okay. Which of the following reactions is an example of redox reaction? Okay. See, in the redox reaction, one should be getting oxidized, one should be getting reduced. So if you look at choice number 3, over here xenon is +4, here it is +6, fluorine is -1, oxygen is +1 over here, whereas oxygen over here is 0. So xenon is getting oxidized, whereas oxygen is getting reduced. Isn't it interesting that oxygen is getting reduced? Normally oxygen is the one which is oxidizing others, right? Here oxygen is getting reduced. So dear friends, this is all about the P block elements. We have tried to make a very concise and short session for you guys, and every line that we have written over here is an important one and can be asked in the exam. So I hope you have understood and you have enjoyed this session and you are ready for the exam. All the best.